out of 61 points, 28 out of 61 points, 36 out of 61 points, 34 out of 61 points. That's ridiculous when it's completion. So I'm going to do the best that I can to make you do your homework every day by saying we are going to have small homework quizzes every day or every other day, depending on what I decide, which means you need to make sure that you're doing your homework. I'm not a big fan of this because I like giving you extra days to do it. I feel like it helps you, it gets you, sorry, I don't remember if I started recording now. I feel like it helps you prepare for college by me not checking your homework every day, so I'm still not going to check it. But I am going to pick some every day that we will have a little homework quiz over because I need you to do your homework because it's the only way that I can say I'm doing my best to help you pass. So here's some other things I have to say about this. These will be shorter than normal ones because we still have a lesson to do every day. In my other classes in Algebra 2, when I taught Algebra 2, we did a homework quiz every day, and it was always on a sheet of paper like this. In College Algebra, we do a homework quiz every day, so it just fits on here. Usually I make you copy one or maybe two problems from your homework, and then I usually give you one that you have to work out on your own. Like 5 minutes is all it should take because we still have to do notes. So they'll be very quick, but it'll be checking that you do your homework. So if you're not doing your homework, then it's going to add up a lot. Some people say it'll be good because if I miss one homework, it'll only affect one day's homework quiz instead of one big homework quiz all being a 0. This next one's kind of long. Well, not that one, but I'll show you both. All right, I'll just let you start reading that. I do, with your name on it and everything. Oh, that's Alice. What ISS have I forgotten? Take it, guys, we don't have one. If you're absent, you have to take it up just like you always do. It'll just be shorter. This is something that I want to try to start doing. In second hour, they do a really good job of this already because they always want to talk to each other and not listen to me anyway. But when you get in here every day, instead of waiting for me to say, hey, get your homework out, you need to come in, you need to get your homework out, and if you have some questions, you could say, hey, I didn't get number 14. Can you tell me how you did it? Not, hey, can I steal your paper so I can copy exactly what you got down for 14? Right? That's not what I'm saying to do. I'm saying you can discuss questions that you had. Oh yeah, you just need to graph that. Oh, you need to complete the square. You need to do this. I think you did this wrong, right? Those are the kind of things that we should be seeing. Because we're going to do a couple questions together every day, but we're not going to spend 20 minutes on homework. That's where you need to see me before school or after school, or hopefully maybe this collaboration with each other can help. Yeah, that's just... And then I'll say, what homework questions do we have? So hopefully if you had like 5 homework questions, maybe your neighbors and you can figure out a couple of them, and then we can do a couple in class together. I got lots here. Number 6, participation, right? So if you choose to just keep talking about whatever you're talking about and not do this policy, then that could count against your participation. Maybe you don't have any homework questions because you know how to do it all. That's great, but maybe you could facilitate someone else around you, right? Yes, sir. Oh, look, that's the next line. Not a change, but a reminder that you get 2 points a day for participation, which is 10 points a week that I give you. 10 free points, and all you have to do is stay awake, take notes, pay attention, start your homework when I give you homework time. And you don't know how many people in here lose participation points every week for one or more of those violations. This is pre-calculus class, right? Like, I shouldn't have to be telling you, don't sleep in class, you need to take notes, if there's time left to work on homework, you better start your homework. Right? Like, I shouldn't have to say that. That should be, oh, that's great, I get 10 free points a week. But lots of people don't get 10 free points a week. Text in class, like, I shouldn't have to say that either, but sometimes I have some issues with that. You know. If there's time left at the end of the period, there's a lot of people in here that choose to use that time to read a book, or just talk to each other, or just sleep, or any of those other offenses. Use your time, right? A lot of people in here say they have trouble on the homework. Start your homework so you can get help for it, all right? So I do keep a little log, and I put -1 sleeping, -1 homework, -1 notes, and I keep a little log so that if you have a question of why you didn't get your participation points, I have a log of what day and what offense occurred. I'm not going to tell you, like, this. You guys are juniors and seniors. I'm not going to, except for when Bryce sleeps and I yell at him sometimes. If you choose not to work on your homework, I might say once, hey, let's start our homework. But then after that, I just mark it down. Like, you guys know what you should be doing, and I'm not going to baby you and say, if you don't start your homework, I'm going to take your point away, right? Like, you need to know that. So that should not be points that you're losing every week. 10 points a week times 9 weeks, that's 90 points. So if you don't ever do your homework, that's 90 points that goes in the homework category that could help on the homework issues of something. Anyone have a question about this new policy? I did this new policy last year too. I'm not a big fan of it. I was hoping I wouldn't have to go back to it because I don't like giving homework quizzes every day. I like to give you time to go back and do your homework. I know you guys have lots of stuff to do, and sometimes you can't do your homework every night, but I feel like that's the only solution. Yes. Yes. Yes.
We still have the normal size quizzes on the worksheet days.
No. I mean, it randomly could be, but for the most part, no. Like, we're going to just do small homework quizzes 2 to 3 times a week. Right? Probably a minimum of 2 times a week. Maybe sometimes 4 times a week. So you need to do your best to get your homework. I'm hoping that means, not that I miss having people in my room all the time, but I'm hoping this means that people will come in for extra help more when they need it, because it seems like right now the only time I ever get people in my room are test days, and I still only get like 3 or 4. If you don't understand the homework, every single night you should be in my room the next morning if you don't understand it. If you have more than 3 to 4 questions on your homework, you should be in my room the next morning before school. Even if you don't come until 8 o'clock, school doesn't start until 8:23. That gives you 23 minutes that you could get extra homework questions answered. Or if someone else is in here in the morning, then you could even work with them and you don't even have to talk to me so much. But you need to be seeing me, not waiting till the day of a test to say you don't understand the chapter. We should be doing this day by day because it all builds on itself.
What time do you get here?
I usually get here about 7:45. I try to open the door back there if you park on this side. If it's not open, you can knock on my window or Mr. McClurg's window, and we'll prop it open for you. I take Parker to the bus at 7:55, but then I come right back. So sometimes if someone's in my room, I'll say I'm taking the bus, and I'll be right back. But I'm usually here by 7:45 at the latest. All right, so we have to do better because right now, I know I haven't graded this test yet. It's the beginning of the 9 weeks, but right now grades overall are pretty pitiful. So hopefully this will make it better. On that note, let's start a new chapter. How about this? Mr. Burgess came into second hour class today during this whole spiel and did a walkthrough with me while I'm yelling at them about their grades and doing homework. That's right. It went well. Well enough. Remember, you don't have to write all this junk down. We are starting chapter 3, which is logarithm chapter. Maybe that's a good note. Remember logarithms from Algebra 2? ln's and e and half-lives. Remember those problems? Exponential decay. Radioactive isotopes. That's some of this, but not today. We're not doing radioactive decay today. We are going to talk about what an exponential function is. Exponential functions and logarithms go hand in hand because they're inverses of each other. But today we're only going to talk about exponential functions, what their graphs look like, how we write their equations, and we're going to talk about our lovely number friend e that gets left out in the cold. Do you need a pencil, sir? Oh, Bryce. I need you to be more organized than I. Exponential and logistic functions, they have a huge amount of applications, lots of science applications. You've probably done lots of science stuff, like half-life stuff. Did you do that in chemistry class? Yeah, we do half-life stuff in here. Population growth, you talk about that in biology with the logistic models. There's even stuff with like mortgages and interest rates that fit into this category. And so lots of applications. People say, when am I ever going to use this? E and exponential stuff, there really are lots more applications than the stuff that we just did with all find the linear factorization. I can't really give you a real-life example of that. But this stuff I can. So let's talk about what these functions are real quick. And I even wrote 3-1 on this page in case you're behind. A couple little vocab things, and then we'll get to some problems. Transcendental function, that's a vocab word I feel like that you don't ever hear about until precalculus class. But the functions that we're going to learn about in this chapter are transcendental functions. And the definition of that is a transcendental number are numbers that are not the solution of a polynomial equation with integer coefficients. That means they get kind of weird numbers. Pi is a transcendental number. The square root of 3 is a transcendental number. Maybe. On my little top 10 reasons I didn't do my homework back there. It used to be up here, but now it's back there. There's one of them is I ate too much pie and I had transcendental indigestion, which you don't get if you don't know pi is a transcendental number. Even if you do get it, it's not that funny. But I like to give you this definition so you at least get that joke back there. On that blue poster right there, David Numberman's top 10 reasons I didn't do my homework. My favorite one is I didn't know if it was I am the square root of -1 or I is the square root of -1. Because a little math and English humor together. Yeah, because it's I is the square root of -1, but you don't say I is hungry, right? Only I find that funny, but I truly do. All right. So here we go. Definition of an exponential function. I want you to write this down, and then we'll kind of talk about what it all means. See if I trick over this in this class. I did a better job of recording better. The big focus today is what is an exponential function and how do we write it. And so this is kind of our big definition of the day. Why I keep holding this say no to jerk pencil. I did, didn't I? It wasn't really yelling, it was just a firm talking. I used to yell a lot as a teacher, and I don't feel like I really yell that much. I say that for my children. Just like we have slope-intercept form, and just like we have vertex form of a quadratic equation, exponential form functions have like a base model. Like this is what exponential functions should look like. And this is kind of your base model here. Instead of mx plus b, instead of a times x minus h squared plus k, that's vertex form, exponential functions should look like this. The big focus is that x is in the exponent. That's what makes an exponential function. And then there's just some rules here. A has to be non-zero, because what if a was 0? What would that whole function be? 0, that's not an exponential function. B is positive, that's just because it goes with what we're doing here. And b can't equal 1. If b was 1, then 1 to any power is still just 1, so that doesn't make an exponential function either. So those are just kind of some rules that they set that all exponential functions follow. Some questions on your homework today, I think the beginning of your homework, they give you a function and they say, is it exponential? If so, state the initial value and the base. The initial value is the number that you multiply in front, and the base is whatever number is raised to the x power. Yes? Maybe? If it doesn't look like that, it's not exponential. If x is not in the exponent, it's not exponential. X can be any real number, though. X can be a square root. X can be anything that you want it to be when you plug it in. So that looks kind of awful at first, but then you're going to see these first examples, and you're going to be like, oh, this is our homework, because it's really kind of practicing using your calculator. Yes, dear?
What did you say about if x isn't something that's not exponential?
If x is not in the exponent, like that's kind of my big definition. What makes an exponential function? X is in the exponent spot. So x is up there as an exponent. So what if I gave you a problem like this that said evaluate each expression, and this means round to the nearest thousandth. How many decimal places is the nearest thousandth? 3. Tens, hundreds, thousandths. I just gotta say that because lots of people give me 4 because they think thousand means 4. And so some of these questions you just get to practice using your calculator, which means I really want you to practice these in class, because on your test that we have for this chapter, there'll be one day that's with a calculator and one day without a calculator. And on the calculator day, some of the questions are just practicing typing stuff in your calculator. So if you don't have a calculator with you, I'm going to hand deliver one for you right now. Perfect. And you can just type this in your calculator, right? You just plug that in and you say, oh, if I'm doing f of -2, that would be 3 to the -2. Some people in second hour said, well, I don't want to do a decimal on that. I want to leave it as a fraction. And I could, just to throw it out there. What would you do to get rid of that negative exponent if you didn't have a calculator? Move it in the bottom. So do you agree that that's the same as 1 over 3 squared or 1 over 9? But you can just type it in your calculator because your book says you can. And I think that you get, if we go to 3 decimal places, 0.111. If you don't get 0.111, you should tell me because we want to make sure you're using your calculator correctly. Did you know that ninths are all repeating decimals like that? 2 ninths is 0.2222. 3 ninths is 0.3223. 4 ninths is 0.1111. Sorry, I thought I had a question with the calculator. What about 9 ninths? How come it's not 0.9999999? Oh, how about that? That's a little math conundrum there. 8 ninths is 0.88888. I always say because it just rounds up. 0.9 repeating has to be 1, right? I don't know. Isn't that weird? How about that? I hurt your brain today. Do you know what I learned today from Pride Time? If you have a felony, you can't vote ever. How did I not know this? I mean, maybe it's because I don't have a felony or I don't know anyone that has felonies, but I feel like that's a pretty harsh punishment.
Is that negative x?
Yeah, that's straight to the negative x. Did you guys all know this? I did know that actually. Is a federal offense the same as a felony? I don't know my laws very well about breaking the law. But anyway, I feel like that's a harsh punishment if you have a felony. But then everyone's like, well, if you murder someone, you shouldn't be able to vote. And I'm like, well, if you're in jail, you shouldn't be able to vote. But what if you're rehabilitated, and you want to vote? I feel like that's pretty harsh. Just saying. I need to go to Mr. Rhodes' class and have a talk to him about it. This one I couldn't do without a calculator because I don't know what 3 to the negative 4 ninths power is. Make sure you type that in your calculator correctly and round to 3 decimal places. I do have to say that if you don't round correctly, then I will take a half point off. So make sure if the number after the third decimal is 5 or bigger, we round up, right? So on this one, we would say 0.614. Yes, did you get that? No? Oh, because you have to put, your calculator is doing it to the negative 4th power and then divided by 9. So you need to put parentheses around that.
There it is.
Alright, so sometimes people think it's silly to just practice stuff in your calculator, but when we do those half-life problems, if you don't use your calculator right, you can't get the right answer. So that's why we practice with this. So that's some of your homework tonight. That's good, right? What else is on your homework tonight? Graphing. Oh wait, just kidding. That's after this one. This is also on your homework tonight. Just jumping the gun here. We did this with quadratics where you had to write an equation, and lots of people missed that problem on the homework quiz, on the worksheet, and on the test because you kept trying to do slope, right? Quadratics don't have slope. Exponential functions don't have slope. So if they give you a bunch of points or an XY chart or a graph with a couple points on it, and they ask you to write an equation, please don't do slope. Right? Slope is only for linear equations. And when you write a linear equation, you start with the slope formula. When you write a quadratic equation, you should start with the quadratic formula. When you write an exponential function that passes through these points, you should start with our formula that I just gave you on the first slide of an exponential function formula, which was a times b to the x. I don't know why I listed so many points. I think because the one in your homework lists lots of points, so I was trying to be cool and do one just like the homework. So I'm going to kind of give you some hints on this one that will help you. Because if you didn't have this one to do, I think that sometimes it's kind of hard to know where to start on this. We had to figure out what A and B are in this problem. Here's a big nice thing. Every time they give you one of these problems, they're going to give you when x is 0 And that's where you should start, and I want to show you why. So once you get this written down, plug in 0 for x and 12 for y, and watch what happens, that you can solve for either a or b every time if you start with your, what would that be, your y-intercept. So if I plug 12 in for y and 0 in for x, I get 12 equals a times b to the 0. And what is any number to the 0 power? So do I get that just a equals 12? If you go back and look at our definition, a stands for the initial value. Think about what initial means. Initial means where you start. If x is 0, your y value is always going to be your initial value there. So you can do this every time, or if you just see this y-intercept, that's always going to be your initial value. Because when you plug 0 in, that's always just going to equal 1. Does that make a little bit of sense there? Or you can just plug it in and solve it every time. Someone said, what happens if they don't give you that point? They're always going to give you that point right now because we don't know how to do it otherwise. Eventually we'll learn, but not right now. So now I could say f of x equals 12 times b to the x. Kind of like slope, when we find slope first and we plug that in and have to go back and find the other one. I need to find b. Can I use any other one of those points they gave me and plug it in there to solve for b? Because I could plug in the x and I could plug in the y. Which looks like the easiest point that I could plug in to solve for b? Yeah, I would pick 1 and 4 because I would just plug in 1 there. You can really pick any of them. Philip in second hour, he wanted to pick -1 because he thought it was easier, and I don't know, to him it was. But I think 1, 4 is the best choice because I can plug in 4 for y, and if I just plug in 1 for x, all I have to do to solve that problem is, divide by 12? And I get that b equals 1/3. That's my base. And just like any equation that we write, put it back together. Plug in a, plug in b, so you get y equals, or f of x equals 12 times 1/3 to the x power, where 12 is your initial value, 1/3 is your base, and that would give you all those ordered pairs that you could even check. I think there's a couple of those on your homework tonight. Make sure you try them. I'm sure we'll talk about one tomorrow, but make sure you at least try them because I know that's going to show up again.
So did you just pick those two because it was 0?
I always pick 0 first because if you didn't pick this one, you can't solve for both a and b at the same time. All right, so always start with this. After that, you can pick whatever you want. Like any of those points, you could solve for b correctly. Why did I pick this one? Because that gave me b to the first power, right? As opposed to if I picked this one, I would have had b squared, and I'd have to take the square root. Or I'd have a negative exponent, and I'd have to move it down. And so I picked 1 just because it was easier. Sometimes they might only give you 2 points, the 0 and 1 other point, so you have to use the other point. Okay, but yes, you definitely want to start with the 0. All right? So maybe that, I don't know, I feel like that might be the struggle today on the homework. But the other stuff is graphing, and I know you did this in Algebra 2 last year, and we'll see how much you remember. And if you remember a lot, we maybe won't have to graph so much in our notes of what these look like. So let's see if we can graph this right quick. Mostly, I just want to remind you of what these graphs look like, and if you think about exponential, then maybe you have some memory of this. And I'm just going to start by picking a couple points to remind you of what happens here. You don't have to make a real fancy graph here. But just think about the points that you pick for 2 to the x. If you plug in 0 for that, you get 2 to the 0, which is 1, right? If you plug in 1, you get 2 to the first, which is 2. Plug in 2, you get 2 squared, which is 4. We call these exponential because they just keep getting higher exponents on them, right? What happens if we plug in negative exponents, though? Like, what happens if I plug in -1 for x? Do I get a negative number? We get fractions, right? 2 to the -1 means flip it over, so you get 1/2. If you plug in -2, you get 1/2 squared, or 1/4. which means, am I ever going to get a negative number when I plug them in? Am I ever going to get 0 when I plug them there? No, and so that's the big thing I want you to remember about these, is these have a horizontal asymptote, just because there's no value that you can plug in there. So if you make a few points here, my graph's really light here, but I can squint my eyes a little bit and see these dots. Right? 1, when I plug in 1 I get 2, when I plug in 2 I get 4, and then I get 1/2 and 1/4. And it looks something like that, roughly speaking. And if you have a positive number to just x, it's really always going to look like that. It just changes how quickly it rises. Like if I did 5 to the x, it's still going to be 0, 1, but instead of over here, it'd go up to 5, and then it'd go all the way up to 25, right? Like it just goes really fast. But it's still that same idea. We call that exponential growth. I had another one here, but we skipped it, and we're going to skip it in here too, since it's right time. I'm going to skip this one. Because 3 to the x is going to look just like 2 to the x, only it's 3. But I want to remind you what happens, so we'll change that to number 5. What's going to happen if I graph 2 to the negative x? If I plug in 0, I'm still going to get 1. What's going to happen when I plug 1 in there? Yeah, now it's negative when I plug a positive number in, so I'm going to get 1/2. And when I plug in 2, I'm going to get 1/4. What happens when I plug in negative numbers? Yeah, it flips around, right? So when I plug in -1, those negatives cancel out, and I just get 2. And so I think, if we think about our transformations, a negative up there means it flips over the y-axis. So now this side is getting bigger, like this, and this side is getting smaller. Still never gets to 0, still never gets a negative y value out of it. And we call that exponential decay, right? Maybe vague memories of that? We're also going to throw in those transformations. The transformation rules still apply. So I have one example here with a few different problems, just to remind you of the rules. There's some on your homework today that say describe the transformation and graph it. XY chart always works, but you should be able to tell me, like, is it reflected? Is it moved up? Is it moved down? Is it moved left? Is it moved right? And just like before, I don't really care that much about stretches and shrinks. They are going to give you some, but I don't care if you recognize that as much without having to make an XY chart. All right? A couple things we could say about this. What would we say about the domain of both exponential growth and exponential decay? The domain is always going to be all real numbers. Even with transformations, the domain's always going to be all real numbers. But what about the range on this one? What would the range be? Including 0? Not including 0. That range can change depending on the transformation, right? If we move that graph up or down some, it's still going to have a restricted range, but it might not always be 0. What's the y-intercept always on these graphs if there's no transformation going on? It's always 1, because when you plug in 0, you get 1. So y-intercept 1. Right, so just kind of think about that as you're doing your other ones, and then you can use that idea to do your transformations. Right, so I'm going to skip the next page for a minute because it's just talking about all that we just did. And so now let's look at this. Transformation. Still 2 to the x, but I want to just kind of talk about what this does to your graph. So it's up to you if you want to graph them all you can. If you just want to write what's happening, I'm okay with that too. But just be aware of reminding yourselves, it's been a while since we did transformations. I'm going to graph this same old 2 to the x. I pick 2 to the x all the time because I can graph a lot of numbers on it. All right, 1, 2, 3, 4, 5, 6, 7, 8. Like if I pick 3 to the x, it goes to 9 and then 27, and I can't graph that many numbers, so that's why I pick 2 to the x a lot. This would be f of x. totally missed that dot. That's okay. We just did one where the negative was up on the x and it flipped it over the y-axis. What is the negative out in front going to do to our graph? Yes? Reflect it down over the x-axis, right? So a negative in front reflects it over the x-axis, a negative inside the function reflects it over the y-axis. If you forget that, make an xy chart. Graph it, and then look at the graph and say, oh, it reflected. But the idea is, if you know your transformations, you don't have to make an xy chart. You can just say, oh, I'm going to take this whole graph, and I'm going to flip it down. So instead of 0, 1, it's going to be 0, negative 1. Instead of 1, 2, it's going to be 1, negative 2. And then you can just make that same graph flipped over. That's why we push transformation so much. It's supposed to make graphing easier, but you can always just make an xy chart. Remember the difference between these? What does it mean when I add a number up there with x? 2 to the x plus 1, where the plus 1 is up in the exponent. Which way is that going to move? Remember? Left or right? Right? Up in with the function is left or right. Outside the function is up or down. And remember, left or right, it's the opposite of what you think. So plus 1 actually means left 1. If I can spell left. Which means that one hasn't changed a lot. I'm going to take this same graph, and I would just move it left 1. So instead of it here at 0, 1, it would be at negative 1, 1, and then 0, 2, and then 1, 4. And it's just going to kind of be scooted over some. And what about when it's added out there to outside the function? What happens there? Up 3, right? Outside is up or down. That's what you think. That one I think is an important one to think about because that changes your asymptote. It changes your range. It takes that entire graph and shifts it up 3. So instead of 0, 1, it's at 0, 4. So if I've moved it up 3 and my normal asymptote was y equals 0, what's my new asymptote? Y equals 3. That number right there will always be your horizontal asymptote. That's why if nothing's added to it, it's y equals 0, because 0's out there. But whatever's there, whether it's positive or negative, will be your horizontal asymptote. Yes.
So up 3 on the last one, is it up 3 from the first line that you drew, or up 3 from the axis, like from 0?
It's up 3. Each dot moves up 3. Does that make sense? So like, it's actually, if you go from the axis at 0, normally you go up 1, so you have to go 3 more than that, so you're really up at 4.
Okay, so yeah.
Does that make sense? Okay. Because you can kind of look at it either way. You can take each point and move it up 3, or you can say, now I'm going up to 4, depending on which way you look at it. All right, so there are a couple on your homework that are graphing. Just try them. We'll talk about them tomorrow. Stretches and shrinks. Don't freak out too much about. The only other thing that's on your homework today, which I know you did last year, but just reminding you, is about the number e. So I just wanted to give you a brief little reminder about this. That e is a number just like pi. E is on your scientific calculator. If you have a phone that has a calculator on it, well, on my iPhone, if I turn my phone sideways, it changes to scientific, and it does have an e button if you don't have a calculator at home. And e, just like pi, goes on forever, but it's 2.718281828, and then it just goes on from there. So e to the x, e is still a number, so it's still an exponential function, but we call it the natural exponential function. And then we have ln, the natural logarithm that goes with it. We'll get to that eventually. This guy right here, he's just who is credited with discovering e to the x and proving what it equals. We're going to do more with this later, but on your homework tonight, you might have to graph e to the 2x. And e is a crazy decimal, so when you're graphing e to the 2x, you just need to pick a couple points to kind of see where they are. They're going to be decimals, and you just graph the decimals the best you can. But it's still, when you graph it, is going to look like an exponential function. It's just a decimal instead of like 2 to the x. Did you have a question? Oh, look, how about this? This is a proof of it really quick. This is what E equals. If you go on forever, look at this is some calculus talk here. So E is defined as the limit of 1 plus 1 over n times n as n goes to infinity. So if we kept adding this up, 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, all forever, that's what E adds up to. So you might say, how can you add up something that goes on forever, right? But as you keep doing this, these numbers just keep getting smaller and smaller, and so like eventually he probably stopped. Like he probably only went so far, but I don't really know how he proved it. We could look it up, but that's where the definition comes from. How about that? And in chapter 9, we're going to add up things that go to infinity. Infinite sums we're going to do. That's our next chapter after this one. So nothing as cool as this, but he gave the approximation to 18 decimal places, and I think that was in like 1600. So that's pretty impressive. Here's what you have to do today with this. Besides graphing, what if I gave you a question like this that said, evaluate f of x equals e to the x if x equals 2. And again, that's where you get to use your handy-dandy calculators. And on my calculators, you hit that E button first, and it automatically puts a little exponent there. So it says like e to what? And so for this one, you would say e to the second. And then we would round it to 3 decimal places. You've had quicker questions today, but probably not. I mean, yelling at you about homework. I think that's what I know. Because E is like 2.71. Right? Oh. So think about, so what did you get? 8, 5? 9. Did you get that? Anybody else get that? If you do e to a negative number, probably should be a decimal because that's like moving it to the bottom. And again, besides graphing, you have some questions on your homework today that you just to practice doing that. Questions about that? It's kind of a review of last year, but it's kind of a lot of stuff as well. So, skip the clicker questions. Here's your homework, 1 through 13 odd, 15 through 30 multiples of 3, 39. The ones that say describe the transformation and graph, I do want you graphing those by hand. Alright, so if you don't know the transformation because it's a weird stretch or shrink, I'm okay with that, but you should be able to like tell me reflections, tell me if it's moved left or right, tell me if it's moved up or down, and then you might have to make just an XY chart. So John Nick Pierre, this big quote is from him, he's the father of logarithms, and then I have a little joke for you. What sound does a tree make if you hit it with a drumstick?